Past few days, we've been discussing arithmetic sequences and geometric sequences. Hopefully, you have a good understanding of those sequences. Today, we'll be learning about the explicit formula, and this formula is used to determine a future term in the sequence. So we're usually just dealing with the first 5 terms of the sequence. But what if we wanted the 100th term of the sequence? If you were looking at a sequence as day 1, day 2, day 3, day 4, day 5, and thinking of it as a trend or a pattern of what's happening, you would want to maybe predict on the 100th day what's going to happen without having to list 1 through 100 terms. That would be very time consuming, and I don't think anybody has much desire to do that. So we have the explicit formula that we can derive from our sequence to use. So we're going to first start with arithmetic sequence. So this one was, remember, always adding. So we have our formula given right here. All right. And I gave you what all of those little variables stand for. So what does a sub n mean? That a with the little tiny n down low. What does that mean? It's the nth term in the sequence. A sub 1, a with the little 1 next to it, is the first term of your sequence, the first number that you have listed. D is the next one. D is your common difference. So to get from one term to the next, what did you add? N would be the term number. So which number in the sequence are you looking for? Are you looking for your first term? Are you looking for your second term, your 100th term? That's what you would be plugging in there. And then n minus 1 represents the previous term number. But really you just need, in most cases, you'll just need that n, what number you're looking for. And then what comes out is going to be that nth term in the sequence. So let's do our first example, see if we can tie all of that together and have it make some sort of sense. So we have our n, which is our term number. This is also our domain. So thinking ahead, we're going to have to describe domain and range. What we're plugging in right here, this is our domain. It is the independent variable, what we're plugging in. And then what we get out is the nth term. It is also our range, what we are getting out. So the dependent variable, and I'll write it up here again. Okay, so again, plug in the term number, the number in the sequence. We plug that in. That's our domain, our independent variable. What we get out is our range, our dependent variable, and it's the nth term of the sequence. So if we were maybe thinking of these as just simple days, domain would be the day 1 through day 5. That's our domain. We plug that in, and what do we get out? Maybe we're talking about money. So the first day you made $7. That's your range. Range would be money. Day 2 you made $11. Day 3 you made $15. You're plugging this in, and you're getting out this. Okay, so domain would be number of days. Range would be the money you made that day. All right, that was a really long tangent there. Let's get started. A1. A1 is our first term. What is the first term in our sequence? First term is 7. And our common difference, we know it's a common difference because they used D equals, and we're using arithmetic sequences. Common difference. How did I get from 7 to 11 to 15 to 19 to 23? We added 4. So I will write 4. Now we're going to use that information to create the explicit formula for this sequence. So we have a sub n equals our first term, a sub 1. We know what a sub 1 is. It's 7. Plus d, which is our common difference. We know that is 4 times n minus 1. So every time we do this, this is changing and this is changing. Everything else stays the same. All right, use the explicit formula to find the 25th term. So we are saying we need to find when n equals 25. What is the 25th term? Or on the 25th day, how much money did you make? So we will go A, and everywhere we see an n, we will plug in 25. So we have A sub 25. That means our 25th term equals 7 plus 4 times n, which is 25, minus 1. So A sub 25 equals 7 plus 4 times 24. We have A sub 25 equals 7 plus 4 times 24 is 96. 7 plus 96 is 103. So if we were to put maybe this in some context that I just totally made up, 25th day, you made $103. Let's try that again for the 71st term. So on the 71st day, how much money did you make? Again, everywhere we see an n, we plug in 71. So A sub 71 equals 7 plus 4 times 71 minus 1. And then we just evaluate, we simplify over there. 7 plus 4 times 70. 7 plus 280. 287. So again, with my made-up scenario, 71st day, you would make $287. And notice you didn't have to list notice you didn't have to list the first term, the second term, the third term, the fourth term, the eighth term, 20, all the way to get to 71. You didn't have to list all of it out. We used the explicit formula to see how much we're making on the 71st day. All right, let's look at example number 2. I noticed that my work kind of got a little large, so I'm just going to shrink that down real quick. Okay. Consider this sequence: 333, 330, 327, 324. What is our first term? First term is the one we see, 333. D, common difference. What's my common difference? To get from one term to the next, we added a -3. Okay. From there, let's write our explicit formula. Explicit formula is A sub n equals A sub 1 plus D times n minus 1. So A sub n equals first term, 333, plus my common difference, times n minus 1. So now let's use that explicit formula to find the 25th term. So everywhere we see an n, we're going to plug in 25. So A sub 25 equals 333 minus 3. And that, notice it was plus -3. Plus a negative is the same as minus. So that's why I made that jump there. Times 25 minus 1. So A sub 25 equals 333 minus 3 times 24. A sub 25 equals 33 minus 62. And when we subtract those, we get 261. Now, notice for this sequence, our numbers are going down, okay? Each term, from one term to the next, we subtracted 3 or added -3. So it makes sense that our 25th term is smaller than all the rest of the terms that are listed. If for some reason you get a number that is larger than 333, you probably made a mistake somewhere and you should go back and fix it. Just like in this first one, notice our values are increasing. So it makes sense that our answers, this 103 and this 287, are going to be larger than the values that were previously listed. If they're not, you have a mistake, go back and fix it. Okay? And the last part here, find the 71st term. I hope that you can guess by this point. Our term numbers are going down, so the 71st term is going to be much smaller than the rest of the term values that we have. So A sub 71 equals 333 minus 3 times 71 minus 1. 333 minus 3 times 70 minus 210, and we get A sub 71 to equal 23. Okay, example 3. Now this one is a word problem. So 19 students showed up for math club at the first meeting. Each meeting, 2 new students joined the club. So on the first meeting, A sub 1, we had 19 students. The common difference, well, each meeting we're adding 2 new students. So our common difference is going to be 2. Explicit formula. So we have A sub n equals the first term, or the first meeting. We had 19 students show up. Each meeting will have 2 additional students times n minus 1. Now, use the explicit formula to find how many students will attend the 9th meeting. Now, we want to know the 9th meeting. Yes, you could list out first 9 terms, but it's asking you to use the explicit formula. If you don't use the explicit formula, I cannot give you credit because that's not what the directions were asking you to do. So keep that in mind. So everywhere we see an n, we will plug in 9 for the 9th meeting. So 9th meeting equals 19 plus 2 times 9 minus 1. So A sub 9 equals 19 plus 2 times 8. 19 plus 16, A sub 9 equals 35. And now since we are using a word problem, I need to explain that answer in the context of the problem to get full points. It will be 35 students at the 9th meeting.